In a new card game, you start with a well-shuffled full deck and draw 3 cards without replacement. If you draw 3 hearts, you win $50. If you draw 3 black cards, you win $25. For any other draws, no matter what it is, you win nothing. So we want to create the probability model of our winnings, so we have to find each value of x and the probability of each x. I find this easier to do in a table format. Okay, first I'm going to put the event, like what actually happens. Then I'll put the actual x value that would be, because remember, random variables are random variables because each x value has a numerical value. So in this case, like what can you win? We're supposed to create the probability of our winnings. So the things we can win are $50, $25, or nothing. Those are going to be the values of x. So let's see, if I draw 3 hearts, then I get $50. If I draw 3 black cards, then I get $25. For anything else, or for all others, I get $0. Those are the possible amounts that I can win. Having the events written down helps me find the probabilities. It's like, okay, well, $50, but how do I get that? I get that by 3 hearts. And then we also want to find the probability for each of those x values. So it's a deck of cards, it's without replacement, that's important, and we're drawing 3 cards. Okay, so if I want to get 3 hearts, we look at this. In a deck of cards, there are 13 hearts and a total of 52. So if I want to get 1 heart, I would have 13 out of 52. But then I don't put it back. So the next time I try and draw a heart, I now only have 12 out of 51. And the next time I try and draw a heart, I only have 11 out of 50, which gives me this 0.0129. Okay, I just put that into my calculator, 13 out of 52 times 12 out of 51 times 11 out of 50, and I get the decimal 0.0129. If you want to write it as a fraction, you can, but that's probably not going to be a very nice fraction. A decimal is a lot easier for us to visualize. Okay, so now if I want to do black cards, let's see. For black cards, that would be both of our black suits. So there are 26 black out of a total of 52. Now notice this is not associated with the possibilities of getting hearts. This is completely different. What would be the probability of getting 3 black? So it would be 26 out of 52. But again, the next time I try and draw black, I've used one, so I only have 25, and there's only 51 total cards. And the next time we'd be at 24 out of 50. Again, it's easiest to report this as a decimal once you get to word fractions, so we just do 0.1176. For anything else, well, that's a lot of possible combinations. I mean, I could have 3 red, 2 red and a black, 2 hearts and a black. There are, probably not infinitely, but there are thousands of different combinations of things that I could get. And I don't want to find the chance or the probability of all of these thousands of different possibilities. So instead, we can use the complement rule, because we know we care about 3 hearts or 3 black, and then just anything else falls into the last category. So anytime you want to find like the probability of anything else, use the complement rule, because we know everything has to add up to 1. So the easiest way to find the probability of anything else is subtract the probabilities you already have. So we'll do 1 minus 0.0129, and we also have to subtract 0.1176. Now the key puts these together with a plus. It doesn't really matter either way, but we know everything has to add up to 1. So 1 minus the 0.0129 minus the 0.1176 gives me 0.8695.